So now moving on to the next presentation. This is coming from HIUV, another leading encapsulation solution provider. We have Rainbow Zheng, who is the overseas sales manager at HIUV. She is going to talk on multi-scenario encapsulation technology for N-type cells. Rainbow, the floor is yours. You were on mute. Can you unmute yourself?
Hello.
Yes, we can hear you.
Sorry. Nice to meet you. Hi, everyone. It's my honor to be here to share with you about HIUV multi-scenario encapsulation solutions for N-type cell technology. I'm Rainbow, and I'm overseas sales engineer in HIUV. So let me share with my screenshot. So is it okay? Okay.
Yes.
Okay, let's start. First is the life degradation of PV modules. As we know that the module is made up of a variety of materials, including glass, backsheets, cells, frames, and so on. We as the encapsulation film supplier is also one of the important links. This figure is a set of data from the IEA in 2014. The module degradation is divided into 3 parts in the infant, module life, and wear-out stages. In the early stage of the module, it is still from the impact of LID. Immediately after that, accompanied by some of the physical attenuation of the module. For example, contact film junction box, string interconnection, glass breakage, as well as the loose frame and so on. With the operation of the module, we will also have the PID issues, and there are some hotspots resulting in these direct burning problems. Also accompanied by some of the attenuation caused by the solder string desoldering. Finally, when the module is used to the end of the cycle, there are some variety corrosion performance problems resulting in its power degradation. The module we made will be used in outdoor, windy, and rainy environment. In recent years, such as lake, snowy, marine, desert, and other multi-scenario modules are also increasing gradually. So encapsulation requirements are more stringent. HIUV is always focusing on product innovation. We are established in 2005, entered the field of PV encapsulant film in 2009. We have successfully developed some leading products. In the year of 2012, we first developed the anti-PID EVA. In 2014, we successfully developed the pre-cross-linked white EVA. In 2018, we developed the co-extruded POE. But after 2018, there is a big change in the industry, mainly in the cell type, which is gradually changed from aluminum backfield to P-PERC to TOPCon and the current heterojunction BC type. We know that there is no one film can fix for all these kind of cells. So we have made some different encapsulation solutions. Today, we are mainly talking about 4 parts. The first one is TOPCon encapsulation solutions. Then heterojunction, OBB, and lightweight double glass single-sided encapsulation solutions. Regarding to the TOPCon part, In fact, we know that it is in the process of uploading the volume. It is really a very rapid evolution of the demand. At present, according to our statistics, EPE products have become a preferred material for TOPCon. For this EPE film, first we need to upgrade the formula to ensure the reliability. Second, we have improved the formula to enhance the cohesive strength of the middle P layer, so that it can have the 100% yield when mixing and sealing, especially for EPE with EVA without the four corners of the frame. At the same time, this EPE product has been fully certified in terms of client reliability. Double EVA film, HIUV actually have a layout of such a technology 2 years ago. It is have 3 advantages. First is water resistance. The second is low acid. And the third is anti-PID effect. This is the EVA film performance enhancement mechanism. To do a summary, there are 5 main points. First is to increase its moisture resistance. Second is to increase the ion trapping agent. Third is to increase the cation barrier. Fourth and fifth are very similar. They are through the low acid treatment to reduce the chemical corrosion and the electrochemical corrosion of the cell surface. LecoCell technology has become one core of the TOPCon cell technology, and we have done some comparative verification. You can see that our improved EVA plus LecoCell darkroom rewarding 2 hours, the PID 119.2 reached a level of 2.6%. This data is from an experiment performed with a combination of the improved EVA and a regular TOPCon cell. The power is in a big attenuation. As the rewarding time lengthened from 6 to 12 hours, the EL was being lit up. After the module came out of the dark room, we put it outside for 4 and 8 hours. We can see that the entire EL has returned to its original state at 8 hours. Let's take a look at the LecoCells. We see a significant recovery at 2 hours, 6 hours, and 12 hours. But the only difference is that after 4 hours of light, it has returned to the original state of the EL. That is, LecoCells are extremely sensitive to light compared with non-Leco. This is the power data. It doesn't matter if you are Leco or non-Leco. As the light is recovered, the power is both increased later. The single glass part may not have as serious PID problem as the double glass part. The main problem still comes from heat and humidity. That is the impact of heat. Here are 2 typical data. These are LecoCells from manufacturer A and manufacturer B. The difference is obvious. Manufacturer A is a case of overall darkening, and manufacturer B is a clear case of corrosion at the edge. In the case of LecoCell from manufacturer A and manufacturer B, the power attenuation will be greater in the case of manufacturer B. This one. Okay, that is the first part of TOPCon. The second part is about the heterojunction. We all know that heterojunction is very sensitive to UV light. we, as the encapsulation films manufacturer, will solve it by some anti-UV agent. In the early days, we used to do double-sided UV cutoff film or single-sided UV cutoff film as encapsulation solutions. Later, we began to change the application to conversion film. The physical properties of our conversion film is that the maximum absorption wavelength is about 360 nanometer. It emits the maximum wavelength is about 417 nanometer. Our conversion material, light emitting quantum efficiency, can reach more than 95%. Our conversion film not only has a better cutoff effect, but also the transmittance in the band of 318 nanometer to 1100 nanometer can be basically the same as the high transparent film. Okay. This is a list of the patents that are currently open to the public. This is the structure of the patent nucleus. HIUV's current conversion film and the powder are all self-developed, which is different from the structure of the conversion powder in the above-mentioned patents. Our conversion film is not within the scope of its patent claims. Here is the reliability test of our conversion film. The conversion film is only used on the front side. For the cell and cell gap part, the conversion film with the time encoding the external environment, such as dry, humid, heat, and UV irradiation, it is actually migrating downward. But this part of our film, no matter under what situation, with what temperature, what UV, including ultra UV, it does not migrate. That is to say, through the performance of this test, our structure is different from others. You may ask if there are any side effects. We can see through the transmittance of the DH and the UV aging testing. So far, the current performance is still relatively good. This is a UV aging test that we did. We have increased from 15 kilowatt-hour to 200 kilowatt-hour. In such a trend, the quantum efficiency of the conversion film must be decreased. From the graph of comparison, the quantum efficiency of our conversion film is maintained at a relative high level. Third part is OBB technology. The module interconnection technology has been transferred from the early SMBB to OBB. OBB technology is currently in different routes on the market. We have done a survey summary. The first technology is a light thermal curing adhesive to fix the welding tape and then laminated with a skin film to form an alloy. The second one is an integral coating on the surface of the cell, which is laminated to form the alloy by means of a heating plate. The third is the welding of the tape and then fixing it with adhesive, which can be achieved by normal lamination with a conventional film or conversion film. The fourth one is the technique of welding tape, lamination plus carrier film. For HIUV, we mainly focus on the interconnecting film of OBB. First, it has to have a low fluidity when forming the metallization alloy. Second, the thermal resistance, no matter high temperature or low temperature, no desoldering. Third, it should have a high viscosity. The welding tape and the cell should have a good fit and bonding. Regarding to OBB, we are mainly concerned about the TC test and the hotspot test. We have done some internal internal verification. The early TC changes, the biggest problem comes from the lag between the cells, EL shadow problem. With the upgrading of our product structure, we have now achieved no change in EL. Okay, this is the last part about the double glass single-sided products. That is double glass white EVA film. This film compared to our normal white EVA film, the biggest difference is that two functional layers are added on the normal white EVA film. The main purpose of these two functional layers, first is to solve the appearance of the module so that it doesn't have overflow white. The other functional layer is to have a high bonding with the glass surface. This product has been in massive production and application for our customers. Currently, the yield rate for this double glass white EVA can reach 100% at the customer site. Okay, double glass white EVA is also adapted to a variety of cells. For example, it is suitable for PERC, n-TOPCon, heterojunction, and the BC cells. Okay, last, I would like to have a brief introduction of our company. HIUV is one of the top 3 companies in the global encapsulation film industry, and we have 128 domestic and international patents. Our total production capacity is 120 gigawatts, and we have been awarded many honors. We have 5 production bases in China and 1 production basis in Vietnam, which will start production by the end of this May and to have a better service for our overseas clients. In addition to the PV field, we also have products in the field of architectural curtain wall, BIPV, and automotive film. HIUV is always leading the new encapsulation technology and always support this industry field. Okay, that's my today's sharing about multi-scenario encapsulation solutions. If you have any question, you may contact with us. Thank you for your time.
Thank you, Rainbow. Thank you very much for this nice insights into the encapsulation solutions. I think I have 1 or 2 questions. So, are there any special treatments in product design for the use of the conversion films in heterojunction applications?
Our company's conversion films and the conversion powder are all self-developed. While the normal products on the market are powder dispersed in the resin film system, our conversion film and the conversion agent react with the matrix resin, so there is no migration of the product.
Okay, so now, as you know, the TOPCon share is really increasing. So what is your company's forecast for the encapsulation materials used for TOPCon, in different technology zones, the encapsulation solutions?
Okay, yes, TOPCon is very hot recently. The market sharing is increasing day by day. Okay, in China, module manufacturers are focusing on cost reduction and efficiency enhancement. Some have already started to use double EVA encapsulation schemes, which have been successfully tested and are currently in massive production with some of the clients. Yes, in that way, they can bring the cost down. Yes.
Okay. Thank you very much. I think there could be a few more questions. in the chat window. So please stay back and enjoy our panel discussion. And if there are any questions, please answer in the chat window. Okay.
Okay,
Okay.
thank you.
Thank you. So.